Let's calculate the indefinite integral of x to the power of 5 times the logarithm of x dx. So again, I always wonder what type of method we should be using in this situation. Because we have a function multiplying another function, it might hint at integration by parts, although that's not necessarily always true. But what we should look at here is the integration by parts will allow us to take the derivative of one of these functions as long as we anti-differentiate the other. So if we look at this, taking the derivative of ln x would give us a 1 over x. So that's pretty good, because that 1 over x would cancel out with the antiderivative of this, which is 1/6 x to the 6th. So in that way, this would appear that integration by parts would be a good idea, and indeed it is. So let's go ahead and do that. We have x to the 5th ln x dx. Okay, so now we have to choose what our u and our dv, or sorry, our u and our dv by dx should be. So again, what you're looking for is, for u, something that's easy to differentiate. Both of these are. But dv by dx should be something that's easy to integrate. Ln x is not easy to integrate, but x to the 5th is. So we're going to choose this to be our dv by dx, and we're going to choose this to be our u. So now we just use the formula for integration by parts. Nope, let's not do that yet. We still need the other pieces. So u, we know, is equal to ln x, which means du by dx is equal to 1 over x. We know that, we don't know v, but we know that dv by dx is equal to, by choice, x to the power of 5, which means v is 1/6 x to the power of 6, because it's the antiderivative of x to the 5. So now we have that u times v is 1/6 x to the 6 ln x minus the integral of v, which is 1/6 x to the 6th, times du by dx, which is 1 over x, and of course we have our dx for our integration. So now I think that you might be able to see why we chose to do this. We had a really complicated and very difficult integral over here, but integration by parts has allowed us to convert this integration into a different integration, namely this one over here. And this one over here is much simpler because we took the derivative of ln x, it's right there, as long as we anti-differentiated the x to the 5th, which is right here. And of course this actually makes this a much easier integration to do, because the 1 over x cancels out with one of these x to the 6th and gives us x to the 5 inside, and we can pull out the 1 over 6 outside because it's just a constant. And so we can actually just go ahead and do this antiderivative now. It's very straightforward. This antiderivative, of course, is 1/6 x to the 6th. We should put a constant on here because it's an indefinite integral, and so let's just clean this up a little bit. 1 over 6 x to the 6th ln x minus 1 over 36 x to the 6th plus a constant. Of course, you could simplify this up a little bit if you want, but I'm just going to leave it here. This is our indefinite integral of x to the 5th ln x.